What if you were told that a fundamental math concept was not accurate? You may recall being taught that pi equals 22/7. However, this is not correct. It's not even close. This is just the beginning of the story of this mysterious number. Pi was not discovered. The story is far more interesting. Today, the real story of pi will be explored. How did we arrive at the amazing number known today? And why were approximations such as 22/7 taught? To understand pi, it's necessary to go back in time, before calculators and computers. Imagine ancient civilizations such as the Egyptians and Babylonians, building massive structures like the pyramids. They needed a way to deal with circles, but advanced math was unavailable. Observation was available. It was noticed that the distance around any circle, the circumference divided by the distance across it, the diameter, was always a little more than 3. The Babylonians around 1900 BCE used an estimate of 3.125. The ancient Egyptians in the Rhine Papyrus around 1650 BCE obtained a value of about 3.16. These were excellent estimates for their time. They were adequate for building, and that was sufficient. However, this was not a discovery, but an observation. The real work began with the Greek genius, Archimedes of Syracuse. He was the first to realize that things could be perfectly calculated using geometry. So, what did Archimedes do? He drew a circle and then created two polygons, shapes with many sides, one inside and one outside the circle. The circle's circumference was between the perimeters of these two polygons. He kept doubling the number of sides on the polygons. He started with a 6-sided hexagon and kept going, all the way to 96 sides. This manual calculation led him to prove that the value of pi was somewhere between 3 and 10/71 and 3 and 1/7. The second number, 3 and 1/7, is the same as 22/7. And it didn't stop with Archimedes. Later mathematicians continued to refine this painstaking method. Centuries later in China, the mathematician Zhu Chongzhi used a polygon with 24,576 sides to get pi to 7 decimal places. Others pushed it even further, to polygons with tens of thousands of sides, like a 32,768-sided one. These calculations took a huge amount of time, but they were the best way to get a more accurate value for pi before the age of modern computing. The story takes another big turn in the 17th century with the invention of calculus and the discovery of infinite series. Formulas like this, though they look complicated, were far more efficient. They allowed mathematicians to manually calculate pi to many more decimal places than any polygon method could. This is how the value of 3.14159, and all the digits that follow it, were obtained. Today, we don't use pencils and paper for this anymore. Calculations for pi have become a race for supercomputers. Using highly optimized versions of the infinite series formulas, supercomputers have calculated pi to trillions of digits. But why bother? Well, these extreme calculations aren't for the value of pi itself. They're used to test the limits of these supercomputers and the algorithms they run. The quest to find more digits of pi is now about pushing the boundaries of technology. This returns to the core point. 22/7 is not pi. The key difference is that pi is an irrational number. This means its decimal goes on forever without a repeating pattern. On the other hand, 22/7 is a rational number. Its decimal is 3.142857, and then the 1,42857 apart just repeats endlessly. Since they have different decimal patterns, they can't be the same number. 22/7 is a fantastic simple approximation, but it's not the real deal. So the next time you hear someone say that pi is 22/7, you can tell them the real story. It's a story of ancient civilizations making observations, a Greek genius performing geometric calculations, and generations of brilliant minds creating new mathematics and technology to reveal one of the universe's most fundamental and mysterious numbers. The story of pi isn't about finding a single number. It's about humanity's unending quest for deeper and deeper accuracy. Peripheria was the translation of circumference in Greek, which was abbreviated to just p.